Okay, all right. So this is a video about how to do stoichiometry with a BCA table, which I think you're going to like a lot. Last year I gave the kids a choice of 2 ways to solve it, and pretty much everybody liked this way, so we're just going to stick with this way this year. Okay, so the first thing you do is you're going to see an equation, right? Chemical equation, and this is sort of like the recipe for how the reaction proceeds. And we've kind of talked a little bit about this going up till now. Last unit we did a little bit with the energy and the moles of energy released, whatever, okay? But you want to think of this chemical equation like a recipe for how the reaction will proceed. Just like hopefully previous to this you did that simulation with the cheese and the bread and the meat, right? It's basically like a recipe. 2 pieces of bread, 1 piece of cheese, 1 piece of ham makes 1 sandwich, okay? So the first thing you're going to need to do always is balance, okay? And this one is pretty easy to balance. So this is going to be 1, 2, 1, 1. All right, and I'll keep the balancing pretty simple, hopefully, just because, you know, we're sort of in a weird situation. So, all right, so the first thing you're going to do is balance. And just for now, in the beginning, I want you to just think about drawing particle diagrams, okay? Just so you can kind of see what the recipe looks like. So here's a lead, here's a lead. All right, and let's do the H as orange, and I'm going to have 2 of those. Okay, and then the Cl, let's do that as a green one. Cl, and that's going to be PbCl2. Okay, so we can see that this is balanced. Okay, all right, so what you're going to do from here is, if you see here 1 lead, 2 HCl's make 1 lead 2 chloride and 1 mole of hydrogen. All right, but you might not always have these exact amounts, okay? So now we have to start thinking about, what if we don't have 1 mole of lead, 2 of these, 1 of these, 1 of these. All right, so if I have 4 moles of lead to start with, all right, you can see that's a super easy one, right? So instead of 1 of these, if I had 4 of these, how many HCl's would I need? Right, I'd need 8, right? Because that's a 1, that's a 2, is the same as 4 to 8. If I need 1 lead and now I have 4, I'm going to get 4 of these and 4 of these, okay? So in effect, that's what you're doing. So don't overthink it, because it's actually simpler than you might tend to make it, okay? All right, so how we're going to fill out this chart is B stands for before, C stands for change, and A stands for after, okay? So the first thing you're going to do is you're going to fill out what you have before the reaction starts, okay? So we can see that we're starting with 4 moles of lead. So I'm going to put 4 moles right here, okay? And then it says we have excess hydrochloric acid. That's the HCl, okay? Sometimes there'll be a number, sometimes not, but usually one of them runs out first, right? And one of them gets used up. I mean, one of them gets all the way used up, and then one of them you have extra of. Just like, remember when we did the nail lab, right? The nail and the copper switch places, and then the copper completely ran out because the solution became yellow instead of blue, and there was still nail left over, okay? So the thing that's left over we're going to call excess, so you just write an XS in that, because we don't really care about that, okay? Before the reaction, the products, we don't have anything because that's the product. We haven't run the reaction yet. All right, so that's how you fill out the before line. All right, then the change, right, we're going to use up something all the way. Okay, so since the HCl is in excess, we don't care about that. So what we're going to do is we're going to use up all 4 moles of the lead to end up with nothing left over. Okay, the lead is going to get completely used up. Okay, so this is the given amount. This 4 moles of lead is the given amount. So that is what you're going to base everything else on. Okay, right? So basically the first thing you want to do is you want to pretty much copy over this 4 moles into all these boxes. Okay, so the reactants are going to have a negative in the change because you're losing reactants. Okay, and the products are going to have a positive change. Okay, notice how I'm writing it on the left side of the box because I have to write something else. Okay, so the products are going to have a positive change because I'm gaining product. Okay, all right, now If it was just 1, 1, 1, 1 up here, right, we would be done because every 4 is going to make 4 everywhere else. But that's not the recipe, right? This is a 1, this is a 1, and this is a 1, okay? So then those ratios are going to basically be 1 to 1, all right? So you always put the thing on the bottom that's the given, right? Because this is 4 moles of lead, right? So I want the recipe for the lead under here. So this is going to be 1 mole of lead, okay? And you don't have to write all of these numbers every time. I mean, all of these labeling, or else it's never going to fit, okay? But in effect, that's what you're doing, right? You have 4 moles of lead on the top, and that's going to cancel the moles of lead on the bottom, et cetera, et cetera. Okay, so the given thing always goes on the bottom, and then what you want goes on the top. Okay, so here I have 2 HCl's. So for every 1 mole of lead, I'm getting 2 moles of HCl. Okay, for every 1 mole of lead, I'm getting 1 mole of PbCl2. And for here, every 1 mole of lead, I'm getting 1 mole of H2. All right, so you don't have to write all of that. If you want to, you can, but it'll get faster as you go, okay? So here, I started with excess, and then I lost, in effect, I lost 8 moles of lead, right? So this is a -8 change, okay? But in this case, it doesn't matter because I had plenty to start with, so I just still write excess because I don't even care about that one. It's not even relevant, okay? But I'm losing here 8 moles. See, remember, that's what we set up here. For my products, 4 times 1 over 1 is just going to be 4. So I'm going to make 4 moles of lead chloride. Same thing here, 4. This is a 1 to 1 ratio. I'm going to make 4 moles of hydrogen. Okay? All right, so in the word equation now, you're going to have to make the specifics to what you have, not the recipe anymore. You're going to use these BCA table to write it. Okay, so I'm going to say 4 moles of lead. Oops, does not start with a P. Oh, God, jeez. Okay, 4 moles of lead. And if it said solid, whatever, we could put it, but this one doesn't. Combine with, I'm just going to say excess hydrochloric acid. Okay, because it gives us the name up there. Or you can say hydrogen chloride, that's fine. To form 4 moles of lead 2 chloride and 4 moles of hydrogen, probably gas. Okay? All right, makes sense? It's confusing at first, but it will get easier, okay? But you have to practice it. All right, so let's try another one that's slightly tougher, okay? All right. How much chlorine gas is needed to fully react 6 moles of phosphorus? How much phosphorus trichloride is produced? Okay, so again, remember for the naming, I'll try really hard to put the names if you don't know what they are. Okay, and you can always Google them because, you know, whatever at this point, who cares? Okay, all right. So the first thing I need to do is balance. So I have phosphorus, chlorine, and PCl3. So here I have that 2, 3 thing. So I know I'm going to have to do this to make them both 6. Okay, so now I have 6 chlorines here, 6 chlorines here, but that gave me 2 phosphorus here, so I need 2 phosphorus here. Okay, and for the particle diagram, I'm just going to draw this. Make sure that this looks like this, right? These 2 phosphorus need to be separated. So maybe we're still kind of, I don't know, drawing it kind of whacked out. Okay, so I'm going to have 2 phosphoruses over there. Okay, and then I have 3 diatomic chlorines. Okay, so make sure those look connected. I really love drawing on this iPad, I'm not going to lie. It's pretty nice. Okay? And then PCl3 is going to be like this. Okay? So remember, this is just a picture of the recipe. Okay? This isn't really a picture of actually what's happening because I'm actually going to have 6 moles of phosphorus. All right? So again, don't make it too confusing. What you're going to do is you're basically saying 2 moles of phosphorus, 3 moles of chlorine make 2 phosphorus trichlorides. Okay? So you can sort of pre-think about this one because this number is simple. They're not always going to be this simple, okay? So if 2 of these, if I actually had 6 of those, right, I have triple the amount that I had before, okay? So if I have 6 of these, I need to triple everything pretty much, right? So this 3 is going to become a 9. This 2 is going to become a 6. Okay, so that's what the answer is going to be, right? But we're going to go through the process because it's not always going to be this easy, okay? So before, how much chlorine gas, right? So I'm kind of looking for this one, is needed to fully react 6 moles of phosphorus. Okay, so this is my given, 6 moles of phosphorus. Okay, I want to know this, all right, and I also want to know how much phosphorus trichloride is produced. So I also want to know this. Okay, so the nice thing about the BCA table is it just, you figure out everything about the reaction. So it doesn't even really matter what you're looking for. You're just going to do the whole problem. Okay, you might think that sounds like extra work, but last year I promise you everybody was like, this is way better. Okay, so we're just going to skip the other way, which is kind of harder. Okay, all right, so I don't know how much chlorine I start with. I do know I start with 0 moles of the product because the reaction hasn't gone yet. Okay, all right, so my given, right, my given is 6 moles of phosphorus, so that's going to get completely used up. So I'm going to lose, that's why it has a minus, 6 moles of phosphorus to get nothing left. Okay, and then I'm going to carry that over to all of these columns. Okay, I'm going to go ahead and write the labeling in there, okay? But you don't have to do that, right? Once you kind of get the pattern of it, it's super fast. You don't have to write all of the units. That kind of defeats the purpose of the table, okay? But just while we're learning, I'm going to write it. All right? Okay, so 6 moles of phosphorus, then I'm going to need a ratio, okay? Remember the given thing that I had, okay, which was this one, right? This was my given, okay? So I'm going to write that one on the bottom, okay? So now I'm going to look at the recipe. So I have 2 moles of phosphorus, and then let me look back at the recipe and see every 2 of these, I get 3 of these. 3 moles of chlorine, and for every 2 of these, I get 2 of these, 2 moles of PCl3. Okay, and again, if you'd like to always write the units, go ahead. If you don't, that's fine too, all right? So see, that's going to cancel, and then I'm going to get the amount that I actually have. Okay, so -6 times 3 over 2, all right, is basically 3 times 3, which is 9, okay? So this is still going to be a 0 because afterwards the reactant is used up. So up here, I would have had to have 9. So this is like where I'm going to put the so-called answer, okay? So 9 moles of this. And then I lost this amount to get nothing. Okay, over on the product side, I started with 0. 6 times 2 over 2 is just still 6. I'm going to get 6 moles of this after. Okay, which again, look, see, we already kind of knew that. Right? That, we already kind of knew that. But again, it'll get more confusing. Okay, so the word equation, remember now it is not based on the recipe anymore. It's based on what you really have. So I'm going to say 6 moles of phosphorus. Okay, make sure you're using the name because some of you are writing the symbols down here, which is kind of not the point. Okay, combine with 9 moles of chlorine to form 6 moles of phosphorus trichloride. Okay, so remember this is a molecular compound, right? Not an ionic, which is the naming's a little tricky. So I'm going to go ahead and probably give that to you every time, okay? Because don't want to mess with it. Okay, that's your recipe. All right. Okay, so the next thing you're going to do after this is there's a reading, which kind of like goes over this. So maybe if you're more, reading visual, that might help you go through it again. And then there's a few practice problems, okay, which I'm going to do the first 2 of those on the next video. And then you're going to do 4 more by yourself. Okay. And please, I'm begging you, you have to know how to do this by next class because then it's going to get harder. So if you do not understand how to do these very simple mole ratio ones, you're going to be in big trouble moving forward. Okay. If you need help, email me. We can set up a Zoom meeting. I'm happy to help you. Okay.